This video is on section 5.6 notes, right triangle trigonometry. So at this point, we've learned a bit about the 6 different trig functions, specifically as they relate to the unit circle. And so now we're just going to talk about them a little bit more in their relationship to triangles. So this is going to look pretty familiar because we related it to the unit circle the same way. But if we take a triangle and we draw it in the first quadrant, you can see that it's got a positive x value, a positive y value. It's going to the right and up. This could be a point xy, and then that would mean that this side of the triangle is a width of x, this side of the triangle is a height of y, and then over here we have the hypotenuse. And even kind of relating it back to the unit circle, they're calling this r for radius instead of h for hypotenuse. But then for all of these we have sine, cosine, tangent, cosecant, secant, and cotangent. And so sine would be opposite over hypotenuse, or y over r. Cos would be x over r, and tan would be y over x. And then for each of these, we would just do the reciprocal. So r over y, r over x, x over y. So we're going to look at 2 different types of problems that we did not see when we were talking about these different trig functions in relation to the unit circle. And that's if you have some values here that are not, root 3 over 2 or root 2 over 2 or 1s or 0s. But what if you have some other values and that forces you to draw a triangle in one of the quadrants? How could you then take that information and find the 6 different trig functions? So here we're going to go ahead and draw this triangle, and it says we have the point 4, -2. So 4, -2 would be like maybe right there. My drawing's not perfect, but there's my triangle. My right angle is not a right angle, but it's good enough. Okay, so here is my alpha. And so since this is the point 4, -2, then that means that this is my x side. It went to the right 4. And this is my 2 side. It went down 2. And since it went down 2, I'm going to call that a -2. Because it went down. So we're not saying that the length is negative, I'm just showing the direction that it went. And then I can go ahead and use the Pythagorean theorem to find the hypotenuse. So I'll say 4 squared plus 2 squared equals r squared. I'm just going to use r because that's what they used. So 16 plus 4 is r squared. 20 is r squared. And so I have to square root both sides. So the square root of 20 is the hypotenuse, or the radius, if you think about how far away from the center you are. And one thing to keep in mind when we're drawing these triangles in each of the 4 quadrants is that this hypotenuse here, or thinking of it as the radius of a circle, while we can have the x value and the y value as a positive or a negative, depending on if they are to the right or left would be negative, up or down would be negative. The radius side, or the hypotenuse, is always going to be a positive value. So I'm going to write that off to the side because that's just something you have to remember. The hypotenuse is always positive. Okay, so root 20, I'm going to simplify. This is root 4 times root 5. The square root of 4 is the biggest square root that goes into 20 evenly. So that's 2 root 5. So the hypotenuse is 2 root 5. Okay, so if alpha is right here, then that makes -2 the opposite side. 4 is the adjacent side, and 2 root 5 is the hypotenuse. And then I'll be able to find all 6 of the trig ratios. So sine, cosine, tangent, cosecant, secant, and cotangent. Okay, so sine is opposite over hypotenuse, and I'm going to have to show a little bit of work for that one because I'll have a radical in the denominator. So opposite over hypotenuse, the 2's are going to cancel out, and I get -1 over the square root of 5, and then I have to rationalize the denominator, so get rid of the square root in the denominator. I'm going to multiply by root 5 over root 5, and I get negative square root 5. Root 5 times root 5 is just 5, or you could say root 5 times root 5 is the square root of 25, which is 5. And so there's sine. Cosine is adjacent over hypotenuse, so again, we're going to have to show some work here. So 4 over 2 root 5. The 4 and the 2 we're going to reduce. So we're going to have 2 over square root 5, and then I'm going to rationalize this. So this is 2 root 5 over 5. So that's cos. Okay. Tan is opposite over adjacent, so -2 divided by 4. That can be reduced to -1/2. And then from here, we just have to flip all of these. So I probably don't want the reciprocal of this because then I'd have to fix it again. So I'm going to go back here and I'm going to take the reciprocal of this version. So root 5 over -1 is root 5. For cos, I'll take the reciprocal of this version. So root 5 over 2 gives me secant. And then for tangent, I have 2 over -1, which is just the whole number -2. Okay, so there's my 6 trig ratios when they gave me a point to go through. Next, we have an example that gives another way that they could give you this type of problem. It says, find the values of the 6 trig functions of the angle alpha in standard position if cotangent, so cotangent is adjacent over opposite, if the adjacent and the opposite sides are 2 and 3, and if sine is a positive ratio. So here they specifically did not give you a quadrant to draw the picture in. You have to figure out the quadrant that the picture would be drawn in. So I'm going to put this little drawing off to the side. We had this in 2 versions of this, and I think it was the section 5.2 notes. One of the versions of this just told you if the x or the y coordinates were positive or negative. So in the first quadrant, both signs are positive. In the second quadrant, the x is negative, the y is positive. In the third quadrant, they're both negative. In the fourth quadrant, the x is positive, the y is negative. And I'm just picturing, you know, a point graphed here would go to the right and up. That's why it's positive, positive. A point graphed here would go to the right and down. That's why it's positive, negative. And then I can think through, based off of this, I can think through which trig functions would be positive. Like this tells me that cos is positive, sine is positive, and then y divided by x is tangent, and so tangent is positive. And then if sine is positive and cos is positive and tangent is positive, then that means the other 3 trig functions are positive as well, because they're just the reciprocals. So in quadrant 1, all 6 trig functions are positive. Over here we have cos is negative, but sine is positive. Y divided by x would make tangent negative. So here, sine was the only one that was positive, and then if sine is positive, that would make cosecant positive as well. Over here we have cos is negative, sine is negative, but tangent is y divided by x, and so tangent would end up being positive here. For this one, we have cos is positive, sine is negative, and then y divided by x would make tangent negative. So here cos is the positive one. And then, of course, if we know sine is positive, we said cosecant is positive. If we know tangent is positive, then we know that cotangent is positive. If we know that cos is positive, then we know that secant is positive. So in section 5.2, I gave you two different diagrams. One had x and y points and which one was positive and negative. The other one had the actual trig functions written out, but I think it only compared sine and cosine. I don't think it had the rest. So this is one way that people memorize it. They use the acronym all students talk constantly. But all of the trig functions are positive. Sine is positive, so cosecant. Tan is positive, so cotangent is too. And then cos is positive, so secant is too. So this matters because between cotangent being positive and sine being positive, we'll be able to narrow down where our picture should be drawn. So this is a lot of summary information that gets us to where we need to be for this problem. So if we know that cotangent is positive, then that basically tells us that tangent is positive. So that means we're in quadrant 1 or quadrant 3. And then sine is positive. So we were in quadrant 1 or 3, but sine has to be positive. And sine is positive in quadrant 1 or 2. So that means we have to be in quadrant 1 because quadrant 1 is the only quadrant where cotangent would be positive and sine would be positive at the same time. So I'm going to go ahead and draw my picture in quadrant 1. And I have adjacent over opposite. My adjacent is 2. My opposite is 3. And then I can go ahead and use the Pythagorean theorem to find the hypotenuse. So 2 squared plus 3 squared equals r squared. The square root of 13 cannot be reduced, and so I'm just going to say that the hypotenuse is the square root of 13. The hypotenuse is always positive. Everything should be positive here in the first quadrant anyway. And then I'm going to go through and find all 6 trig ratios. So sine, cosine, tangent, cosecant, secant, cotangent. Okay, so sine is opposite over hypotenuse. So 3 over the square root of 13, I have to rationalize it. So I'm going to multiply by root 13 over root 13. And that gives me 3 root 13 over 13. Adjacent over hypotenuse is 2 over square root of 13. And I have to rationalize it. Tan is opposite over adjacent, so 3 over 2. Cotangent, we already knew, 2 over 3. Okay, and then for cosecant and secant, we just have to take sine and cos and flip them. So here is sine, we're going to flip that one, and cos, we're going to flip that one. So root 13 over 3, root 13 over 2. And there are the 6 trig ratios. All right, on the next page, it says solving a right triangle. So the first thing, this is all about solving a right triangle specifically, but nothing describes what they mean when they say solving a triangle. So when they say solve a triangle, they mean find all the missing sides and all the missing angles of the triangle. That's what they mean. Now here, your textbook labels right triangles in a very specific way. So we're going to draw just kind of like a formula of how they label a right triangle so that we can always come back to this and know exactly what they're talking about when they just give you random side names and angle names and you have to know what they mean. So here they have side A, B, and C. A and B are the legs of the right triangle. C is the hypotenuse. We're kind of used to that from the Pythagorean theorem. And then the angle that is across from side A is what they're calling alpha, the Greek letter alpha. The angle that is across from side B, they're using as the Greek letter beta. So it's just a capital B that's got like a long tail. And then across from C, they're using the right angle. So they're not naming this side, they're just making it the right angle side. Okay, so here they asked us to solve the right triangle in which angle alpha is 30 degrees and the hypotenuse, or side C, is a length of 6. And if they want us to solve the triangle, that means that they want us to find all the missing angles and the missing sides. So I'm going to go ahead and finish these labels here. So that means they want us to find side A and B and angle B. So here, if we have this 30-degree angle, that means that A is the opposite side, B is the adjacent side, and C is the hypotenuse, right? So here are just some things. You can use the Pythagorean theorem to find the length of a third side when the lengths of two sides are known. You're going to use trig ratios to find missing sides or missing angles. And then you can use the fact that the measures of the angles of a triangle is 180 degrees to determine a third angle if you know two of them. So here we know two of these angles, and so we can go ahead and find angle B pretty easily. So I'm going to do 180 degrees for a whole triangle minus a 90-degree angle minus a 30-degree angle. So 180 minus 120 is 60. So angle B is 60 degrees. Angle beta is 60 degrees. I already know that. Now I can go ahead and find sides A and B. And so it doesn't matter which one you do first. I'll go ahead and do A first. So in relation to angle 30, this is the opposite side and the hypotenuse is 6. And opposite and hypotenuse tell me either to use sine or to use cosecant. And I'm always going to stick with sine, cosine, and tangent because those are the buttons on my calculator. So I'm going to say sine of this angle, sine of 60 degrees is, of 30 degrees. That was the angle in my triangle. Sine of 30 degrees is opposite over hypotenuse. Okay, so there is how I can solve for A. And then to solve for B, I could either solve for A first and then use the Pythagorean theorem. That's one option. Or the other option is I could just use trig functions and just set this up right now. And so I'll go ahead and do that. This is adjacent and hypotenuse, and so this would be cosine. So cosine of that same angle is adjacent over hypotenuse. Okay, so sine of 30, A over 6, I'm going to multiply the 6 over to the other side to isolate the variable. So 6 times sine of 30 degrees is A. I'm going to do the same thing over here to isolate the B value. I'm going to take the 6 and multiply it. 6 times cos 30 degrees is B. And now here I can just evaluate these. So sine of 30 degrees is actually a value that's on the unit circle. So since I know that, I'm going to go ahead and use it rather than use a calculator and get a decimal. So sine of 30 is 1/2. Cos of 30 is root 3 over 2. So there's 30 right there. Sine of 30 is 1/2. Cos of 30 is root 3 over 2. Okay, so the length of A is 3. The length of B, 6 divided by 2 is 3, so the length of B is 3 square root 3. And so I've solved the triangle, I've found the missing angle and both of the missing sides. All right, solve a right triangle in which side A is 4, side B is 6. And they want you to find the acute angles. So angle B, angle A. Okay. So here we can find C pretty easily. We're going to do the Pythagorean theorem. 4 squared plus 6 squared equals C squared. 16 plus 36 equals the hypotenuse squared. 16 and 36 is 52. And so the square root of 52 is the hypotenuse, and we can reduce this. The largest square root that goes into 52 is 4. And it's 4 times 13 is what gives you 52. So this is root 4 times root 13, and so the hypotenuse is 2 root 13. Okay, so that's one missing side. And then now we need to find the missing angles. So we've got, we can solve for either of them, it doesn't matter. If I use angle alpha, because that's what we often use, is angle alpha. 4 is the opposite side. 6 is the adjacent side. And so tangent is the trig function that uses opposite and adjacent. So I would say tan of alpha is opposite over adjacent. And so to solve for alpha, I'm just going to do tan inverse of both sides. So alpha is tan inverse of 4 over 6. And I'm going to make sure when I type that into my calculator that I use, that I put my calculator into degrees. And the reason that I know that I'm in degrees is because when we talk about triangles, we talk about triangles having 180 degrees, not, 2 pi radians or pi radians or whatever. So my calculator is in degrees, so now I can do second tan, 4 divided by 6. And the instructions said to write the angle to the nearest tenth of a degree. That's 1 decimal place. So this is 33.7 degrees. And then to find the other degree measure that I'm missing, I'm going to do the entire triangle minus 90 minus the 33.7 that I just found. And I get 56.3, and so beta is 56.3 degrees. And so this is solving the right triangle. I solved it because I found all of the missing information, but the acute angles to the nearest tenth of a degree, these are the 2 acute angles. Okay. So next we're going to look at application problems for right triangle. So 2 things you need to know with application problems is that they often give you, when they're giving you the wording to tell you to draw a right triangle and to use trig functions to solve it, or to use the Pythagorean theorem to solve it, they'll often describe something as an angle of elevation or as an angle of depression. And when they do that, they're telling you how to view the angle or how to draw your picture, and in the picture which angle they're talking about. So when you have an angle of elevation, the angle is drawn so that the initial side of the angle goes straight out, and then the terminal side is measured up from the initial side. So you go straight out and up. The angle of depression, you have the initial side of the angle go straight out, and then the terminal side is measured down. So you go straight out and down. And so it creates your triangles in slightly different places, and it's pretty specific. Angle of elevation is something that's usually pretty intuitive to students. The way that they draw the picture naturally tends to be right. Angle of depression tends to be a little bit counterintuitive, and a lot of students will end up drawing it wrong if they're not paying attention. So just be careful to watch out for that wording. Okay, so for example, we have a guy wire is 108 meters in length, and it runs from the top of an antenna to the ground. If the angle of elevation of the top of the antenna sighting along the guy wire is 42.3 degrees, then what is the height of the antenna? So we have a wire that we've got somebody down here, a person or whatever, and we've got an angle that is an angle of elevation, so we're going straight out horizontally and measuring up. And here's the wire, and then here's the antenna, and this is what they're measuring the height of. So we're going to say, if this is the angle, this is the opposite side. This is the hypotenuse because it is across from the right angle, which is right there. And so that means we're going to be using sine as our trig function. Sine of the angle is opposite over hypotenuse. And you can name the side that you're solving for. You can name it whatever you want. You could put h for height if you wanted. They used y because this is the vertical value that they're trying to find, and they used y on the other page of notes. So it doesn't matter. You can use whatever variable you want. All right, so to solve for y, we're just going to take the 108 that is currently being divided, and we're going to multiply it to the other side. So 108 sine 42.3. And for most of these problems, pretty much all of these problems, unless explicitly stated otherwise, since we were talking about triangles and triangles have 180 degrees, you're going to make sure that your calculator is always in degrees when you type these. So my calculator was in degrees a second ago. It's still in degrees. So I've got 108 sine 42.3. And so that antenna is 72.7 meters. These notes, I should have done a better job. I should have said what I wanted them to be rounded to. The nearest tenth is fine. When you're doing an assignment on my math lab, just look and see what it says about how much you should round and make sure you do that. In a testing situation, I would definitely make sure that I was very specific for that. All right, next says from a highway overpass. So here, if you can see it, we've got like a little bit of a, well, it's an overpass, but a little bit of like a bridge here, and then we've got people driving under it. The overpass is 14.3 meters above the road. The angle of depression of an oncoming car is measured at 18.3 degrees. How far is the car from the point on the highway directly below the observer? So here you can't see it very well if you printed this in black and white, but there's a person right here, and it says angle of depression. So they're talking about here's straight out, here's the overpass, straight out and down. So I'm going to draw the triangle like this, straight out and down. So there's our 90-degree angle. Here's our 18.3 degree angle, straight out and down. They said that the overpass is 14.3 meters high. So they measured it right here, but I'm going to label it on our triangle. So 14.3 meters high. And they want to know how far is the car from the point on the highway that is directly below the observer. So the car is right here. The point on the highway directly below the observer is right here. So they want to know what this distance is right here. They want to know this distance right here, which is really just this in the triangle. So if you can see when we do the angle of depression, the triangle that you're working with is a little bit counterintuitive. You really have to think through the problem. So they gave us the height, but it made more sense to label it over here. And so when we drew our triangle, we had to put the height over here on the triangle. When we talked about the context of the problem, they were kind of measuring it right here, but I had to go up and label it up here in my triangle. So that's just one thing to kind of keep in mind when you do an angle of depression. Okay, so here's our angle. 14.3 is the opposite side. X is the adjacent side. And so we're going to use tangent for this one. So tangent of 18.3 degrees is opposite 14.3 over adjacent, which is x. And so to solve, this is a little different than the last one. This was easier because you were dividing by a number, and so you could just take the number and move it over, and it was just one step and done. Here we're dividing by a variable, and so this makes the problem a little different. So I'm going to multiply by x just to make it so the right side is no longer a fraction, but I'm not done because x is not isolated yet. So this leaves me with x times tangent. And to solve for x, I'm going to take that tangent of 18.3 and I'm going to divide it over to the right side. So x is 14.3 divided by tangent of 18.3 degrees. So I'll say 43.2. And that was meters. So this point directly beneath the observer, from the observer to the car, this horizontal distance right here is 43.2 meters. Okay, last we have a tunnel under a river. So this right here is water, this is a river, this is a tunnel that goes underneath the river, is 196.8 feet below the surface at its lowest point. If the angle of depression of the tunnel is 4.962 degrees, then how far apart on the surface, so here's the surface, how far apart on the surface are the entrances to the tunnel? So here's an entrance, there's an entrance. And then how long is the tunnel itself? So they want to know how far apart these are, they want to know this, and then they also want to know how long this part is right here, this part of the tunnel and that part of the tunnel together. So I'm going to kind of draw this bigger. So we have the 196.8 and the 4.962. I'm going to go ahead and call this the radius. I'm going to call this the x value. So I know that this distance right here is 2 of those x values. So how far apart on the surface are the entrances to the tunnel? 2 of those x values, because we have this left triangle and then we have a symmetric triangle over here on the right. So I'm going to have 2 of those x values. And then how long is the tunnel? That's this r value that I'm using for the hypotenuse. I would have 2 r values, one for the left, one for the right. So in relation to this angle, 196.8 is the opposite side. X would be the adjacent side, and R is the hypotenuse. All right, so to solve for X, we already have the opposite side. X is the adjacent side. So if we're solving for X, we're going to be using tangent. So tangent of 4.962 is opposite over adjacent, 196.8 over x. So to solve for x, we're going to do just like we did with the last problem. We're going to multiply the x over to the other side. X times tangent 4.962 degrees equals 196.8. And then to isolate the x, we're going to take the tangent and divide it over to the right side. So x equals 196.8 divided by tangent of 4.962. So this is that horizontal distance. The entire thing tells us how far apart the entrances of the tunnels are. So 196.8 divided by tangent of 4.962. So I'm going to go ahead and round to the nearest tenth. And what I'm going to do before I get rid of this decimal on my screen is I'm going to go ahead and multiply it by 2. So the entrances of the tunnel. And that was feet. Okay, and then now for the hypotenuse, you could use a trig ratio to solve for r, or you could use the Pythagorean theorem. One thing to keep in mind is if you use the Pythagorean theorem, you would be using this x value, and you cannot use a rounded value. You cannot use 2266.7 and just plug that in. You'd have to use the actual exact decimal that was from your calculator, okay? You cannot use a rounded value. You have to use the exact answer. So what I'm going to go ahead and do is, instead of using the decimal for my calculator, I'm just going to set up another trig equation to solve. So I'm going to say for this, I have the opposite side and the hypotenuse. That would be sine. So sine of 4.962 equals opposite over hypotenuse. And then it's going to be just like this process again, but instead of having tangent, we're going to have sine. So I'm going to multiply r to the other side. And then to solve for the r value, I'm going to divide sine over to the right. So r is 196.8 divided by sine 4.962. So this is the length of the tunnel just on the left side. And so to get the entire length of the tunnel, I'm going to go ahead and double this.